Welcome to this bonus episode of the Maine Science Podcast. I'm Kate Dickerson. I'm delighted to share this audio recording of our January 2021 online forum, From Maine to the Stars. At this session, we heard from Carl Hoos of Vault Enterprises, Sasha Derry from Blue Shift Aerospace, and Mark Lippold from FMI, a Spirit Aerosystems company. All three talked about their company's place in the growing aerospace industry in Maine. Thanks to our online forum sponsor, Bioscience Association of Maine, and media sponsor Maine Public for supporting the Maine Science Festival and these forums. I've included a link in the show notes to the MSF website with information about the online forums, both the upcoming schedule and where to find the videos of those we've already had. A few notes about this recording. While we've edited for audio, if you'd like to get the full experience of the forum, the video recording found on the Maine Science Festival YouTube channel is your best bet. Due to a technical error on my part, the recording starts after the first minute or so of Carl Hoos's presentation. And finally, this audio recording does have some quality issues. We've cleaned it up as best we can, but did want to give our listeners a heads up.
From SpaceX or any of those similar launch vehicles. And basically those vehicles are like tractor trailers or large buses. They're very big, they're costly, and you have to pack them up. You got to fill the void on those vehicles in order to make it worthwhile. And because of that, the frequency of those launches is pretty low. And so what we want to do is essentially develop a car to space where the cost of the vehicle is much lower, and the payload is, of course, 2 people. So it's pretty small, so we can really increase the frequency. And so that's what we're setting out to do with Vault. And how we do that is you really kind of get an idea if you look at rockets themselves. The majority of the rocket is all propellant, and the propellant is the fuel plus the oxidizer, typically liquid oxygen. And that oxidizer is about 2 to 8 times the weight of the fuel, depending on the fuel you use. And so what we're doing with Vault is basically use the oxidizer or oxygen in the atmosphere to get a large part of the way to orbital speed, which is 17,500 miles an hour, or about 5 miles a second. So when we do that, essentially you're launching vertically. We start off with a short rocket boost, and then we run to that high-speed jet engine, which they call ramjets, and essentially scramjets when it gets going fast enough. And then we finish it off with a third stage rocket going into orbit as you're basically taking a turn and going horizontal to the Earth. When you actually reach orbit, you're essentially in a free fall around the Earth. And we're looking at payloads for our system of about 25 kilograms, which is about 55 pounds. So it's a very small vehicle. And to kind of give you a pictorial of what our competitive advantage is, if you know some of the small rockets that are being developed or have been developed now, the Rocket Lab Electron Launcher 1, which they just reached orbit here a few days ago, their first time. So they appear to be up and running. Firefly, a much larger system, but still small in comparison to something like a Falcon 9. They'll be, I think, launching later on this year, or at least attempting. This is us. This is where we want to be right here. For us, is basically launching these small nano satellites in a small payload capability. But because we're using that oxygen in the atmosphere, it really allows us to scale the system down. And so that's what we're looking for. This gives you a little kind of view of what we've been doing so far. And all of this has been taking place in the state of Maine here. But we're essentially vertically integrated. We do everything from the design of the system, numerical analysis, computer modeling. We fabricate the parts, basically assemble them, do some ground testing, and then follow it up with flight testing. And the flight testing we're actually doing in Maine as well. We've we've been using the blueberry fields in down east Maine to do some of our initial flight testing. As far as launching, we're looking at launching out to the coast of Maine. We have a lot of area going due south, and we can go right over the poles of the Earth, which is one of the prime spots for nanosatellites, because you can get a glimpse of every part of the Earth in that orientation. 3 launch sites that we're looking at: the down east coastline up at Loring, and then also Brunswick Landing, which would probably be a horizontal launch off a plane. So I'll wrap this up. I just wanted to probably give you a little note here. The X-15 program that was started in 1959, and one of the pilots there is actually from Maine, and he actually got his astronaut wings in 1963. So he's out of Madison, Maine. He was a graduate of University of Maine at Orono, and he actually flew most of the flights of any of the pilots in the X-15 program. The X-15 program is really the start to our space age, and these guys actually reached space back then. So
that was really cool, Carl. If anybody has any questions, again, throw them in the Q&A. I do have one question I was hoping before we move on. Could you explain how the oxidizer works, like pulling it out of the air for the fuel?
Yeah, so it's essentially just like a regular jet engine that you would see on a plane now. The air is essentially getting pulled in a typical jet engine through the compressor blades, the fan blades that you see in the front end, and it pulls it in, compresses the air, mixes with fuel, burns, and then runs out the nozzle in the back to create thrust. And essentially, as you get going high enough speed, you no longer need that fan to compress the air. You just adjust the internal design of the engine to compress the air, slow it down and compress it, and then just mix it with fuel and blow it out the back. If you don't need that compressor in the front, you don't need the turbine in the back, so it kind of opens everything up. But ideally, you'd want to change the shape of that engine as you're changing speed and altitude.
Fantastic. We are going to move on to Sasha Derry. Sasha, welcome.
Thank you.
You didn't get the spiel ahead of time, but I sent you a quick message, so hopefully that did it. Sasha is also a rocket. I consider both you and Carl in the startup community. Is that a fair assessment?
Sure, absolutely.
So Sasha is also, and for folks who follow the festival, I know you've probably seen that Blue Shift Aerospace was working on a launch last week, and everything went great except for the weather. And I'm going to let Sasha talk about both Blue Shift Aerospace and what their next steps are. Take it away, Sasha.
Sure. Thank you very much.
And sorry, one other thing, if I didn't hit anything there, feel free to do more of an intro, but all of your information is on our website. So I just thought we'd dive into the content.
Oh, yeah. No, thank you very much. Yeah. So what you see, can you see my screen okay? I just want to make sure I've done that all right. Yep. Yeah, what you see there is we parked Stardust 1.0 right there in the hangar. This is where the F-15s used to fly out of Loring. Everything, as you mentioned, went really well. We were very pleasantly surprised with how we were absolutely technically ready. The weather didn't perform. And I think what was also sort of amazing was the level at which people were so receptive and interested in what we were doing. And I'm not just talking in Maine. We literally got people watching us from all over the globe, across the Americas. There was a whole Latin American contingent. We had over 33,000 viewers of our streaming event. So it just it blew our socks off that people had that much curiosity in what we were doing here in Maine. But so you see some similarities in terms of what Carl was just mentioning. What we're doing, we're pursuing some of the same markets. There is today really only 2 ways of getting to space if you want to launch a small payload to space. Whether you take it suborbitally, that's up and down, or orbitally. There's freight trains of the world, like SpaceX and ULA. that will take thousands of kilograms. And then there's the buses that I refer to as the Virgin Orbits and the rocket labs of the world. And we intend to become the Uber to space. And that's thanks to our technology, our business strategy, and how we're reducing costs, the complexity and risk for launching small loads to space. And as Med, you probably heard, this is the market. Just to launch these things into any of these tiny satellites into space is expected to be a market that's over $69 billion over the next 10 years. So we are really thankful that we received grants, several grants from MTI, it's the Maine Technology Institute, and also NASA. But thanks to those and our team, the geography, which I'll get into, of Maine itself, and you heard a bit from Carl, and what we found as an unfulfilled niche market, and frankly, a whole lot of persistence. We've been doing this since 2014. And I would say a dash of Yankee ingenuity. Blue Shift is poised to take advantage of an incredible aerospace opportunity here in Maine. So I think that everyone knows that, the biggest challenges with rockets, they're complex, they're expensive, they're dangerous. And we have solutions to all those things. And we in the process over the last couple of years, we've interviewed over 40 different potential customers in this niche market that we're looking to go into. And we discovered that they were almost all of them were having the same problem. And those problems weren't being addressed. They were second-class citizens on all launches to space. They had no control of where they would go into space. They were just lucky to catch or hobo on any larger freight train or bus to space. Nobody was catering to them specifically. We also further learned that this market there was this particular niche market made up of student and professional researchers who would not only be delighted to have a dedicated launch vehicle, an Uber to space, to carry their payload to space, but we actually found that they would pay more. And we also found that Maine gave us a particular competitive advantage. Maine. That could only be found in a military base in California, which is expensive, or from launching from Alaska, also logistically incredibly expensive. Now, I think we got this probably a couple times, but I think it's always good to give a sense of how big these CubeSats are. Normally, I would have we have a model CubeSat that I would normally have in my hands. That is in limestone right now with the rest of our equipment. So I don't even have that to hold and show in front of you. But these weigh generally anywhere from a kilogram to 10 kilograms, and they're 10 centimeters cubed, very small. And thanks to shrinking electronics and the decrease in costs, you can do an incredible amount of science and also commercial activities such as broadband services, earth imaging, weather forecasting with these tiny satellites. So under a grant from NASA, our Marvel powered rockets will fundamentally reduce the cost, the complexity, and inherently the risk of launching small loads to space. And that's because we only have to produce one engine for all of our rockets. And you can see all the way to the left, that's Stardust over there. That is a slightly smaller version than the engines that we will produce from here on out. And we will simply produce one engine, put more or less in parallel, depending on if we're doing a suborbital or an orbital mission. And while this won't be the smallest rocket for any given payload, we believe the costs, which is the biggest driving factor, we will have an incredible competitive edge because of the simplicity and the cost to manufacture. It's sort of like we're sort of like the standard. We're sort of like the Southwest Airlines in space, where they just buy one type of jet. Was a 747, I think it was. And that's all they're going to do. Just 747s. They're going to maintain those, fly those. We're going to build one engine. That's it. And use that for all of our different services. Here you see it's a product roadmap going from Stardust, which we're about to launch from Limestone here, and the benefit of using just one engine for all the different rockets. I think you saw this in Carl's slides, but what suborbital means for us is, technically Stardust will be suborbital, won't be going to space, but we will be offering suborbital to space services with up to 5 to 8 minutes of zero-G time, something that a lot of researchers have asked for. Right now, they get 1 to 3 minutes, maybe 4 minutes maximum. Every minute means a lot when you're doing research in zero-G or in the vacuum of space. And so that'll be ultimately with our starless rogue. We'll move on then to red dwarf. We'll be providing, this is actually not, we'll go from suborbital to orbital. We'll be doing suborbital and orbital. And we'll be launching up to 30 kilograms of CubeSats into space into a polar orbit. And as you heard from Carl, this is it. This is where Maine really is distinct. What we found out under, thanks to a study commissioned by MTI and the Maine Space Grants Consortium, that Maine has a unique opportunity to service 50% of the desired orbits for these tiny satellites. Over 50% of these tiny satellites want to go into polar orbit. And we will be the first to take advantage of that, of this enormous geographic opportunity. Nowhere else can you do this on the eastern seaboard. And again, the only other places to do it is in a military base in California or Alaska. The reason they're doing this is to, you can see in the graphic in the bottom right-hand corner here, they're doing it to, you put it into a polar orbit and allows you to do things like Earth imaging, where you see a slice of the Earth and the Earth sort of rotates underneath you and you're able to get a full image of the entire Earth once a day. Or if you just change your trajectory slightly, you can rotate with the Earth and have a constellation of satellites that are constantly providing broadband communications to the whole entire eastern seaboard, for instance. So we are being, we think, pretty conservative about what we plan to do in the first years of operation, but it's an incredible niche market that we think will be very profitable not only to us but also to Maine. Currently in the suborbital industry, I think Carl mentioned some of the competitors. Blue Origin is probably the biggest one. Up Aerospace is another. Virgin Galactic is on the verge constantly of being a competitor in that space, and others. There's actually other competition that doesn't go to space, like high altitude balloons and those parabolic airplanes that give you 0G. In the low Earth launch industry, really there are only competitors that provide large payloads to space, 100 kilograms, 1,000, 2,000 kilograms to space. These are all gigantic ride shares. There's nobody today providing a dedicated small payload for these tiny satellites. Nobody. And by comparison, at Blue Shift, we'll be providing 30 kilograms of payload space. This means a potential customer could consume the entire payload bay and still be considered a nano satellite, a tiny CubeSat, and we would be profitable as an organization. You can see today we've received funding from NASA, and actually Patreon has actually been an important part for us, and MTI. And we've been fortunate that we've already secured 3 customer payloads. They're actually waiting and stored in our rocket, ready to be launched. They were so close to being launched last week. 2 customers outside of Maine. Kellogg's Research Lab is developing a certain special type of material which handles high vibration environments. Rocket Insights, which is launching Stroopwafel in our payload. They're actually a software company that is sponsoring our launch. And excitingly, and this kind of gets to our core audience, the Falmouth, Maine High School developed a 3U experiment in the course of just 2 to 3 months that is loaded up in our bay. And you can see I'm actually literally passing the enclosure for their experiment to one of the students. And that enclosure, if you look in the bottom right, their satellite, or excuse me, not satellite, but their experiment is right there to the right of Luke's hand. And it's ready to go in the rocket right now in limestone. Fundamentally, what it comes down to is that our technology, our strategy enables us to reduce the cost of launch by up to $1 million per launch. We consider this a game changer. And it's really what enables Blue Shift to provide this dedicated smaller launch service than anybody else at competitive prices where no one else can. We've assembled a great team, ready to go. We know there's a few more folks we'd like to get on the team and hire. We have a number of advisors on our team that have been key to our success technically, business-wise, and then we've had some really great composites expertise. So in summary, at Blue Shift, we've identified the market that has unfulfilled needs. We have the technology, we have the team, we have the business strategy, and we have the unique advantage that only Maine gives us to compete in the new space market. Blue Shift will have the future of aerospace. We'll make the future of aerospace have the words "Made in Maine." So thank you, and I'll be glad to take some questions.
Thanks a bunch, Sasha. I actually do have a question. You did not talk about the fuel, which I know is significantly different than what Carl's working on. So, and I know you can't talk about it a lot, but if you could talk about that as a major difference in the way that you're approaching this, I would be grateful.
Yeah, thank you, Kate. I appreciate asking that question. It's something that I think we've understated over the last 4 years for various reasons of what we're up to. But we will, with this launch, we'll be the first company in Maine to commercially launch a rocket. We'll be the first company in the world to commercially launch a rocket using a bio-derived fuel. Our bio-derived fuel is a solid. It's made from substances derived from plants. And it can be had from farms across America. It's completely non-toxic. Unlike, I think, most rockets, if our rocket ditches into the ocean, it will not contaminate fisheries, wildlife. We ultimately look to make our rockets totally recoverable and reusable. But we think we're really making a statement by what we're doing at Blue Shift, by changing the way what we consider responsibility to our favorite planet of them all, Earth. Fantastic air, the food's half decent, the people aren't bad, the wildlife's wonderful.
Thank you. All right, we're going to move on to Mark. Mark Lippold is from FMI Spirit Aerosystems, and in a large contrast to the two folks who were right before Mark, Fiber Materials, I never know how exactly, Mark, to call you, because I just want to say FMI, but not everybody knows what that is. So, but I'm going to say FMI for this part. They've been around since 1969. I was fortunate enough to rope Mark in to present at a field trip day. I think it was our second field trip day, and he had the middle school kids eating out of the palm of his hand, and it wasn't just because it's rocket science and cool. It's because he's so good at explaining what he does. But it doesn't hurt that it's rocket science and cool. And it's a totally different kind of rocket science. I use the example of Fiber Materials as one of the ways I sell the festival, in that we have this extraordinary company here that's been around for 52 years and people don't know about it, and it drives me crazy. So just a little plug there. I think what they're doing is really remarkable stuff. And I'm going to let Mark take it away and explain. And I hope by the end of it, you're going to be as thrilled about them as I am.
So I'm just going to give a brief overview of the company, then talk about our applications, what we're working on, and then talk about one specific application where there's an upcoming flight or upcoming demonstration of our material. So Fiber Materials is part of Spirit Aerosystems. As Kate noted, we were established in 1969. Spirit purchased FMI last year, January 2020. We remain wholly owned, and headquarters are in Biddeford, Maine. In Biddeford, we have 2 sites, about 250 people and growing, a lot of open positions. So anybody who is out there listening and is interested in doing cool stuff like we're talking about today, this is a place you can go and do cool stuff. We're a key supplier in the aerospace industry. We focus on extreme environments, and I'll talk about that a little bit. And our major customers are U.S. government agencies, Air Force, Navy, Army, NASA, and a bunch of prime customers, Lockheed Martin, Boeing, Northrop Grumman. So who is FMI? Really, we're a supplier of composite materials. That's our game. Composite materials meaning fiber reinforced matrix composite, something that is carbon fiber reinforced. Extreme conditions meaning heat, pressure, or shear. And obviously, all of us know composite materials give us very low mass compared to their metallic variants, or what we would be replacing would be metals. Who are we? We're innovators and fabricators, and we're steeped in STEM, and I'll talk about that a little bit. We employ scientists, engineers, technologists, machinists, fabricators, program managers. Just about every type of person out there is somebody we're looking to employ. We're recognized across the industry for the work we do in extreme environments, and are sought out across our customer base. A lot of awards, but I would highlight the one there at the bottom, State of Maine Innovator of the Year in 2018. We're very proud of that award. So what do? We create new materials. I call us a one-stop shop. We're a creator of materials focused on extreme conditions. Part of our strength is we're able to and want to co-engineer with our customers and helping them solve their application problems. We design components and flight systems, develop processes, methods. We do a lot of equipment development in our in-house. In terms of testing our materials, minus 250 degrees F to 5,000 degrees F. There's applications that go over 5,000 degrees that we go out of house for, but that's a pretty robust test environment we're able to perform at our site in Biddeford. And we fabricate all our material and machine all our componentry at our facility in Biddeford, Maine. In terms of what we're supplying, three major areas: propulsion, and we heard a lot about propulsion from the prior two speakers. We work thermal protection systems. I'll talk about that a little bit, and structures. On the first one, propulsion, both solid and liquid, are used on a variety of platforms. We supply materials for both of those, various component types, both the main thrusters and then the steering components, the divert and attitude controls. We also do high temperature insulator work for those components, because if anything's getting hot, you got to be able to hold on to it. So we make materials that are able to hold on to really hot things. In terms of thermal protection, we do atmospheric entry components, anything for ballistic and interceptor missile and hypersonic vehicles. Anything that goes fast gets hot. Anything that re-enters gets hot. Anything that burns fuel gets hot, and we focus on those. We also work on structures. A lot of people don't think about automotive and industrial equipment, but there's a lot of challenging applications inside of the automotive and industrial equipment market. Recent achievements, we've had a lot of flights over the last 2 or 3 years. And rather than going through a lot of these alphabet soup names, I thought what I'd do is just focus on the Mars 2020 EDL, which is coming up in February 18th, about 4 weeks from now. EDL being entry, descent, landing into Mars. So here's an example of a mission program we're working, or did work, now that it's in flight. FMI designed, engineered, and fabricated. This happened in Biddeford. The heat shield for the vehicle, and I'll show a few pictures of the actual capsule and entry vehicle. We built the ablative heat shield. That's a 15-foot diameter heat shield that protects the capsule on entry. Is the largest ablative heat shield ever built to date. That's not just in the U.S., that's in the world. So here's a picture of that capsule sitting in the payload of an Atlas 541 vehicle. I leave it to the other two speakers to explain to you what 2.3 million pounds of thrust is, but you got to get that thing off the ground and moving fast to get to Mars. So after it's launched, capsule shown in the picture below is traveling at 352 million miles an hour. Takes 253 days to get to Mars, and of course, that's when the planets are as close together as they get, and that occurs every 26 months. So you can only launch to Mars, or efficiently launch to Mars every 26 months. The speed it's traveling at as it goes to Mars is the speed it would take to go from Portland to Boston in 6 seconds. So when you think about the speed it's moving at a pretty good clip. So speed in space is one thing, but then you got to get to the planet and you got to enter. There is no capture into orbit at Mars. We actually fly directly into the planet, into the atmosphere. And so when the aeroshell and the heat shield hit the Martian atmosphere, it's going to be going 13,000 miles an hour, which is a pretty good clip, which means when we hit that atmosphere, and Martian atmosphere is thinner than Earth's atmosphere, the heat shield is going to reach 35,000 degrees F. Now, the heat shield we built is a material that was developed in conjunction with NASA quite a few years ago, and we've used it on several missions, and we'll be using it on several missions coming up. But the idea here is to protect the vehicle, but you got to also keep the inside cool. It's got to be strong enough. It's got to be light. So we're able to, with an inch thickness of this material, we're able to withstand 35,000 degree heating on the outside and keep the inside cool from melting the wheels of the rover that's going to be moving around the planet Mars. If I had more time, we'd look at the video. There's a nice video online. If you go to YouTube, 7 Minutes of Terror, it's very interesting about how Perseverance will land on the planet Mars. And I'd also direct you to the JPL website, that's Jet Propulsion Lab, or NASA, for more information. I think in summary, we're doing really cool things at FMI, and the other two speakers, they're doing real cool things. So I think for people who are watching in Maine, there's a lot of opportunity to do fun things that are related to STEM education. So at FMI, we would see STEM science, exploring and discovering the unknown, technology, creating new materials, engineering, kind of dreaming of changes in building, and in mathematics, the calculating and the outcome. So any students tuned in, STEM education is important and very cool stuff. And with that, I would stop and take questions and any comments.
Mark, that was very cool, as always. Do you, how many of the rover landings has FMI been involved with?
We've done the last 2 Mars rovers, and the reason we would be involved is because both of those rovers were lifting bodies. They had a higher L to D. The original ones just basically came ballistically in kind of non-technical terms, crashed into the surface of the planet. These actually have precision landing, so they're guiding as they enter the atmosphere. So they're in the hot zone for longer and actually creating more heat than prior. So all future missions will use our material because it's unique in terms of weight and capability. Currently, we're working on Mars sample return. So this rover is going to collect caches of material. It's going to leave them, and the next mission will go out there, collect them, and bring them back to Earth. So we're working the heat shields for both the landing on Mars and the return of those materials to Earth. So we're working both of those now. Those will occur toward the end of the decade. And people in Maine have the opportunity to come to FMI and help us work on those. Sorry, guys, I'm trying to steal other employees from Blue Shift and Vault. It's a shameless
We're looking
job.
for interns.
Somebody has to do it.
From what I've heard, from what I've seen from all of your presentations, it sounds like there's going to be plenty of work to go around, and you gal will be in a bit of a bidding war. We're going to open this up to questions from the audience. If you have questions, you can throw them in the chat. We can turn on your mic as well if you want to ask it instead of filtering it through us. If you don't have questions, I'm going to continue asking questions. You will all be at my mercy. I did notice 2 out of 3 of you mentioned that you have programs or a product that is first in the world, not just first in the country, which I find deeply inspiring, and also, as weird as it sounds to say, pretty commonfold in Maine. I have found that Maine leads in all sorts of ways that people don't know about. Have you found outside of Maine that people are surprised at what you're doing? You know, the solid biofuel and the heat shield stuff, Mark, is just extraordinary work. Have you found that, are people wondering why you're here?
Well, for FMI, people wonder why we're here. And I would tell you why FMI is here is that years ago when we started, the textile industry was on the down ramp, and there was an ample number of people to do woven products, fiber work. And the state of Maine, Biddeford, was a textile mill town. And so the ample number of people there provided an opportunity. Now people in the industry kind of get who we are. Know we've been embedded for years, and Mainers are Mainers. They like to live where they live because we live in the greatest place in at least the world. I'm not sure the universe, but I know the world is a place to live.
How about you, Sasha? Have people been surprised?
Yeah, you always have the portion of the population that's not quite aware that Maine is connected to the rest of the United States. But once you get beyond that, for sure. I mean, we saw that in our live streaming event last week, that the comments, well, first of all, the comments are coming from people asking, where is this? What's going on? Where in the world is it? Where are they? And why are they doing this in Maine? No, and so you get people poking fun. But that's good. That's fine. I'm delighted that we are setting a surprising example for what a rural state like ours can do, and more importantly, what Mainers can do. So I have a certain delight that we're surprising so many people. And I think the way our path forward in choosing something that's environmentally responsible is particularly Mainer in its intention. So I certainly delight in it, and I think 10 years from now, people are going to consider Maine as maybe not the hub for aerospace, as I joke to tell people that's where I'm from, Maine, the hub of aerospace, but a hub, and a good source of jobs for both students here in Maine who've graduated, but also students from away and other professionals from other states and countries.
Well, I was glued to the screen, but at my house in Portland, the sun was out, and I was not surprised to find someplace else. It was overcast and not cooperating.
Yeah, we heard that from a lot of people. They're like, but it's blue skies out our house. So just go 300 miles north and the weather changes.
It's like every time I take a camping vacation, the same thing happens.
Yeah, it rains.
We're starting to get some questions, but before we go to that, Carl, I wanted to ask, you said you did your launch in the field.
Yeah.
Which the merger of different Maine iconic things right there. How is that? How did you coordinate that with the owners, and why there?
Well, I actually saw an article. I think it was probably the Bangor Daily News, or maybe it was the Portland Press Herald. And this is a number of years ago, and it was essentially one of the folks who's actually the launch safety officer that they were interviewing. But people have been hobbyists have been launching rockets up there for 40 years at the time. Probably it's over 50 years now. So I just took a trip up there, And once I got into the blueberry fields and down east, of course, most of Maine is covered with trees. And so you don't think too much about, launching in Maine. It's more like, out in the desert where you're not going to hit much. But still, there's the trees. There's a very low population density in Maine. It's actually one of the lowest around the country as well. And if you can just, see beyond the trees, I guess, that's where the blueberry fields are, and they're wide open. And so when I saw that, the wheels just started turning, and we got together with the range and launch safety officer of the Tripoli Rocketry Association up there, and we just pulled it together as more like a company launch. But we're still launching under the FAA, what they call amateur high power rocketry waivers, and they really kind of they extended them or adjusted the requirements on that to give essentially the hobbyists and engineers 93-mile altitude under the waiver, potentially anyways, and there's no speed limit. And so when we went up there, it's like, hey, this is, all I saw was a runway essentially. And we were just trying to make the best use of it. And, in order to bring more money to Maine, bring more of this technology to Maine. And people are very surprised when we're talking about what we're doing and the type of propulsion we're doing. But the high-speed air breather side of it is something that I've been working on since my career in the mid-'80s. And I was part of the President Reagan's National Aerospace Plane program that they started back then. And that's where they were using high-speed air breathers to take off from a runway and then access space. And so those ideas have been out there for a while. It's just a matter of executing it. And I think Maine to us is a very good place to do that, where we don't have all the big cities like a number of other places like that. We do have the low population density in the area in Maine, the coastline. So there's opportunity galore here. And I think that as we start building these companies, they're definitely going to recognize it.
Mark, I had a question for you from Carolyn. She wants to know if you can compare the size of the rockets that your stuff goes on compared to Sasha's and Carl's. I don't know if you need a visual for that or.
Yeah, so it is, let me see, what was the comparison? Was a tractor trailer to the small car? I guess those.
Audi TT.
Yeah, freight train to a car, right?
Yeah.
Well, the platforms vary, right? So for NASA programs and, the planetary missions, they're Atlas V and then they're SLS, the next generation rockets. But we also supply, componentry into smaller missiles, tactical missiles that are used inside the DoD, Patriot 3. SM3 goes on the ships in Bath Iron Works. We make componentry for all those. So we're making stage components for those motors, which are solid fuel motors. And then we do a variety of components for, if you think of shuttle type vehicles, hypersonic vehicles, X-15 type vehicles, that are going more toward the scramjet or hypervelocity, like Carl's talking about. We do componentry for those too. So I would say it's small in one way, but then also large in another way. Any place where the fuel is burning, whether it's liquid or solid, and it's getting very hot, we're working those propulsion pieces.
Have the three of you ever worked on a project together, or is that something that would even be feasible? I mean, I can see where FMI could work with the two of you. I'm just throwing it out. I'm putting you all on the spot right now. I'm curious if that's possible.
Well, we would look at both and Blue Shift as customer. And we haven't made a customer call on them, but then again, they haven't called us either. So I think
I left you a message, man. I swear. Just don't call me back.
I think there might be an intersection point, but at the same time, they're fairly early on in development, and metallics that they may be using might be a more tactical path for them at this point, as in terms of cost and availability and a lot of other things. But feel free to call. I'll drop you guys my number.
We've offered to be a booster stage for Carl's hypersonics, but
it's
solids.
Yeah, it's the solids are a bit punchier, cheaper, and they're smaller. Yeah, and it's a very short burn for us. Something that we've used, we use quite a bit in the past. We have worked with FMI in the past. We've done a lot of work for Missile Defense Agency on some of the systems that Mark was talking about, divert and attitude control thrusters, and looking at developing some of the components out of some of the high temperature carbon type materials. And of course, in the hypersonics area that he's speaking of, where the scramjets operate, you're lower in the atmosphere. So when you're traveling at those speeds, 5 times the speed of sound, which is about a mile a second and above, the heat that's generated from plowing into that air so fast, the leading edges of these systems will just get rifling hot. And so that's why you need materials like FMI. So we have worked in the past with FMI under my previous company. We know their materials, we've used them. We've worked on a number of different projects with them. We anticipate doing that again. It was unfortunate that ATS actually came down, but we had another window with the Vault project that we were working with in ATS that had a good commercial market, which we wanted to, really take advantage of. So we weren't kind of strapped just to DoD type funding, because it gets kind of, it changes every 4 years. So it gets difficult.
All right, I got another question for you from Jennifer. This is for Carl and Sasha. There's 2 questions. Number 1, how do you achieve attitude control to make sure you hit the target in orbit? And number 2, is there concern about the number of the nanosats being up in orbit? How long do they stay up there, and do they become debris? So I guess that's 3 questions for y'all to chew on. And I can repeat any of those if you would like.
I'll take a stab at it initially. On the, hitting the right target, you need the essentially guidance, navigation, control system. So you got to know where you're at and where you're going, and then also a way to steer the vehicle. And when you're in the lower altitudes, you can use control surfaces like fins, because the air that you're running against will impart a force on the vehicle that actually turns it. And as long as your system is good enough and probably fast enough in the hypersonic speeds, then you can kind of control it. When you get up out of the atmosphere and there's no air there, then you're talking about the divert and attitude control thrusters, like what Mark was talking about. And these could be cold gas thrusters. They don't have to be hot gas, but something that essentially adjusts the line or direction of the vehicle as you're providing some propulsion. And then, I'm sorry, the second question on that.
That's fine. So the other one, maybe we'll make Sasha go on the hot seat for this one. Is there a concern about the number of nanosats up in orbit, and how long do they stay up there, and can they become debris?
Yeah, I mean, there's certainly a lot of concern about it. Some of it's right on. Any one of these things, if they bump into another something, can create thousands more pieces flying around. Effectively, hypersonic, very fast bullets flying around. Probably the worst disaster was when China blew up one of their own satellites on purpose and created sort of doubling the debris in space. Really reckless on their part. Now, the great thing about nanosatellites and CubeSats, at least for the market that we're going after, is because they're so small, inherently tiny, they cannot maintain their orbit for sometimes not more than a year. But in the best of cases, not more than 5 years, and they will simply burn up through the atmosphere because of the orbit they're in. Now, that's not true for larger satellites. You can talk about Starlink and other ones. They are a bit farther out and have more propulsion systems in there. But for the types of satellites and nanosatellites we're targeting and going to be launching, they inherently recycle themselves. I like to say that my other business is a solar business, a renewable energy business, and the daggone problem with solar panels is they keep on working for decades. And nobody wants to buy more if their panels are working perfectly fine 20 years from now. The beautiful thing about CubeSats is they're coming back down in a few years and they want to put them back up. So we like that model. Selfishly.
Yeah, and I would add to that the nano satellites can be put at lower altitudes, and essentially if you put them at lower altitudes, they can come back in quicker. And because the expense of nano satellites is so cheap compared to the large ones, it gives you an opportunity to put new technology into the satellites much sooner than a large one. So, and if you can keep them at a lower altitude so that they come back, like Sasha said, come back in a year's time, they're going to be out of the stream of all the larger satellites. And so, like Sasha was saying, I think cycling those out is really the opportunity for nano satellites. And you can have these, each nano satellite is essentially a sensor or a multitude of sensors. So you can have a multitude of these satellites in constellations around the Earth. So you're getting points of information at much greater numbers with the smaller satellites. So they have their benefit. They just have to go into large constellations, lower altitudes, keep them out of the track of all the bigger satellites, keep the debris down, and have them come back out within a year's time.
All right, last question. I don't know if this is, if you can answer this quickly or not. For the attitude control thrusters, they're usually small compared to big rockets. This is, as you scale your size rockets, do these systems scale as well, or are they larger proportionally?
In our case, we'll actually be able to benefit from the fact that we're going to be running multiple engines in parallel and be able to vary the thrust to each engine to give us control. We do expect that we'll be using cold thrust engines, cold gas engines, thrusters, But one of the other things that we're looking at is our particular oxidizer can be made to go exothermic. So we can get a little boost from that, and we believe we can sort of double down and use something that's already on board and not have additional gases on there, but actually use the oxidizer itself for some sort of medium heat thrusters for attitude control. And they will scale as we grow the rockets.
Yeah, and I would also say that as your vehicles become smaller, then you can use smaller. You need essentially less force in order to turn them and orient them in the direction that they need to go. So it's they will scale, and you can make these thrusters pretty small.
Well, I would like to thank all three of you gentlemen for letting me rope you into my first ever online webinar. And I would like to thank the audience for your patience. I know that you could probably hear us running around before it all started, since I didn't figure out how to make that not something you could hear. So I really appreciate it. I have a few other people I'd like to thank. Maine is sponsoring these online forums. They're a trade association and a longtime partner of the Science Festival, and they are working and advocating for the fields of biosciences in Maine. And Maine Public has also been a really fantastic media sponsor. I've enjoyed getting texts from family and friends saying, I just heard about the forums. Oh, look at that, Sasha. I didn't even know he was going to do that. A big thank you to Angela Smith for helping out with the Q&A to make sure I didn't miss anything, and my whole team at Maine Discovery Museum and Maine Science Festival. We've got ongoing a series of podcast episodes. Sasha was on one of them. So if you're interested in hearing more about individuals who are doing science in Maine, check out the Maine Science Podcast. And our next session, our next online forum will be in February on February 16th at 1 p.m. It's earlier because we've got one of our guests is from the UK. So that is Maine offshore. It's offshore wind from the UK to Maine. We're going to have a gentleman from the UK and Habib Dagher from the University of Maine. And I'll be running it with a science diplomat out of the UK consulate out of Boston. So it'll be a real interesting affair. And I had no idea that science diplomacy was a thing. So I'm personally super excited about that. So that's the 16th. Thanks again. I find the fact that Maine is putting down our flag, that we can control space, not control. We can lead in space as well as we have on Earth. I'm pretty excited about. So thank you all very much for doing this.
You're here.
Thank you, Kate.
Thank you.
The Maine Science Festival has received support for this bonus Maine Science Podcast forum episode from the Bioscience Association of Maine and Maine Public. The Maine Science Podcast was recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is produced and edited by me, Kate Dickerson, and I received production support from Maranda Bouchard. The variation on the Discover Maine theme was composed and performed by Nick Parker.